Here we have a classic trigonometric integral in which we have a power of tangent being multiplied by a power of secant. The first thing you want to notice is that the power of secant is even. And when the power of secant is even, we're going to follow a three-step approach. In the first step, we're going to save a factor of secant squared of x. So what that means is of the 6 factors of secant, we're going to set aside 2 of them. Now, by set aside, let's take a closer look at what that means. So we'll have 11 tangent to the power of 4 of x. Now, there's 6 factors of secant. Again, we're going to set aside 2 of them. So you're just going to put a secant squared of x kind of off on the side like this. And then if there were 6 to begin with, and we set 2 of them aside, then we have 4 more sort of left over. So we have secant to the power of 4x, like so. So that's step 1. In step 2, we have to use the following trig identity. We recall that the secant squared of x is equal to 1 plus tangent squared of x. But be careful here. Don't use that identity on the secant squared that you had saved. Use it on the secants that were sort of left over. Now, in order for this to work, we have to somehow take secant to the power of 4 and re-express that in terms of secant to the power of 2. So to do that, we will proceed as follows. We'll take the secant to the power of 4, and we'll just strategically rewrite that as secant to the power of 2 of x, and then square that. Don't forget to square it, because then this power and this power, which multiply, give us that power of 4 that we need in this problem. And then you have the secant squared of x that you had saved on the side. So now we can take this secant squared of x and replace it with 1 plus tan squared. So let's go ahead and do that. So we've gone ahead and have done that. There it is right there. The secant squared was replaced with the 1 plus tan squared. Don't forget that you still have the square on the outside. A lot of times it's easy to forget that square. So now we move on to the third stage or step of this problem. We're going to let u equal the tangent of x. This basically becomes a standard u substitution. So recall that when you let u equal a certain function, you then take the derivative. And the derivative of tangent of x is secant squared of x dx. So you'll look carefully and you'll notice right here you have your secant squared of x dx in the original problem, and then you have the same thing right here. This is telling us that the secant squared of x dx will be replaced with a du. So you're going to take this entire thing right here and just substitute with a du. So far, so good. Now we still have the rest of the integral. We had tangent to the power of 4 of x. Now, recall, we said that tangent of x is going to be replaced with u. So these 4 factors of tangent are going to be replaced with 4 factors of u. In other words, you're going to have u to the power of 4. And then we go inside the brackets here. We have 2 factors of tangent. But again, since tangent was equal to u, we're going to have 2 factors of u. So this is just u squared. Again, don't forget the square out here. The next thing you might want to do is factor out the 11. And then you also want to rewrite 1 plus u squared squared as 1 plus u squared times 1 plus u squared. And what that means is you're going to have to multiply that out. Some teachers call that foiling. So we're going to go ahead and FOIL it out. We do the first, and then we multiply the outer ones, so that becomes just u squared. Then we do the inner ones, and then we do the last terms. U squared times u squared is u to the 4th, like so. These u squareds can combine. You have 1u squared plus 1u squared, which of course is 2u squared. So why don't we just change that to 2u squared. Then you have to distribute that u to the 4th. So u to the 4th times 1 is u to the 4th. Then u to the 4th times this term will give you 2u to the 6th. Notice we're adding the exponents there. And then u to the 4th times u to the 4th is u to the 8th. Again, adding the exponents. Now we can finally integrate. So we'll just use standard integration here. We remember that the integral of u to the power of n with respect to u is u to the power of n plus 1 over n plus 1. So you're just basically adding 1 to the exponent and then dividing by the new answer. So you'll have, oops, we're integrating, so we don't need that little integration symbol. So now we have 11 times, this becomes u to the 5th over 5. Then we have 2u to the 7th over 7, and then u to the 9th over 9. add your constant of integration. We're almost done. We just have to replace these u's with the original substitution that we made. Let's recall that originally u was tangent of x. So every u will be replaced with a tangent of x. Therefore, we will have 11 times tangent to the power of 5 of x over 5 plus 2 tangent to the power of 7 of x over 7, and finally plus tangent to the power of 9 of x over 9, and then squeeze in your constant of integration right there, plus c, and you're done with the problem. This becomes the final answer.